All right, today, welcome everybody. We are going to have a Quizziz challenge with rational functions. Hopefully you'll learn a little something while the rest of us are playing. All right, my money is on Lemon Crusoe. Just kidding, I don't know who Lemon Crusoe is. Good luck. Ooh. Hold on, what are the x-intercepts? What are the x-intercepts? Whoa, what are the x-intercepts? So by the way, you would have to know how to factor this up here. All right? So this will be x minus 4 and x plus 2. So this right here, what number would you have to plug in there to equal 0? And what number would you have to plug in there to equal 0? Good luck. If you're not sure what I did there, I factored it. Remember, the numerator is what makes it, deals with the 0 of the function. All right, I'm about to end the question. What are my x-intercepts? All right. All right, let's see what you guys came up with. Here's the leaderboard. All right. All right. So let's take a look at this real quick. Let's take a look. All right. It says what did they say it was? 4 and what? 4 and negative 2. So if we go back here and take a look, what number would you have to plug in to make it equal to 0? A positive 4. What number would you have to plug in there to make it equal to 0? Negative 2. So here's what I want you guys to write down in your journal. All right? X-intercepts are where you make the numerator equal to 0. So what do you have to do? You got to make this somehow equal to a 0. And there's only 2 numbers you could plug in there to make it equal to 0. What else did you have to know how to do? You had to know how to do something called factor. So we factored the numerator. Okay? There we go. Going on to the next question. I'll zoom in and give you hints, unless you don't need them. Whoa. What are the vertical and horizontal asymptotes? There we go. What are the vertical and horizontal asymptotes? Vertical asymptotes go this way. Horizontal asymptotes run this way. All right. So you can look at it on your screen. There we go. Vertical and horizontal. And I did give you guys some hints there. You know, I'm just going to end it. All right. Let's see what you guys got. Oh, watch out for Caulfield, especially if his first name was Holden. All right. So right now, let's take a look at this. What is this? What was this vertical asymptote at x equals what? If that's right here, that's right here, that's right here, that's right here. What are we going to have it at x equals 2? What was it over here? X equals negative 2. And what was the horizontal asymptote at? What'd you guys get? Y equals 1. All right. So vertical asymptotes run up and down, horizontal run left and right. Okay. All right. how is this function transformed from the parent function? Remember, the parent function is f of x equals 1 over x. So basically, you're trying to interpret what's happening right here. What does that do to the graph? We talked about it yesterday. If you watched the video yesterday, you'll know what I'm talking about. All right, and then what else? This has something to do with it as well. Now, once you get this down, what I'd like you to do is put this in your journal, because we're going to talk about what happens after you select your answer. Okay, here we go. So let's take a look at this real quick. Take a look. So what does this right here tell us that happens? What was that instruction? It's going to the right. All right, it's going to the right. How many units? Right, 5. And number 2, what does this one tell us it's going to do? It's going to go down 1 unit. Okay, now listen. Could anybody tell me what they believe the horizontal asymptote? You know what? Let's put HA for short, okay? It's a lot easier, okay? What do you guys think the horizontal asymptote would be, and what do you think the vertical asymptote would be for this particular function? Okay. Now, it's going to actually be y equals -1. Because if it was just this, this is like saying what? 1x to the power of 0, and knowing the rule that if this power is less than this power, yes, it's normally at y equals 0. But if I shift the whole graph down 1 unit, now my horizontal asymptote's at -1. But what about the vertical asymptote? I still make this equal to a 0. So what would our vertical asymptote be at x equals 5? So make sure you guys have this in your journal so you'll know if you're asked about vertical asymptotes. Because, by the way, here's how it works. Here's how I work, guys. You'll see this question again, okay? Except it'll be a different, like you'll have the same equation, but it'll just be a different question. Does that make sense? Same equation, different question. All right. All right, let me pause real quick. Somebody has a question. All right, here we go. Next question. What is the horizontal asymptote? What's the horizontal asymptote? So if your equation was y equals 5 over x minus 2, if it was just y equals 5 over x minus 2, my horizontal asymptote would be at y equals 0. Okay? However, what's happened to our graph? It's been moved up 7. So what'd you guys get for your horizontal asymptote on this one? Y equals what? Y equals 7. So why is it y equals 7? Because there's this pesky little plus 7 that moves it up or down. Okay? So let's see here. All right. Not bad, not bad. You guys are starting to see the patterns here. Okay. Oh, wow. That's hard to see. That is hard to see. What is the horizontal asymptote of the function? So I'm going to highlight it so you guys can see it, hopefully. The horizontal asymptote is this guy right there. So it's definitely y equals something. All right. So you have to figure out of those answers what it's going to be. But that's your horizontal asymptote. Flapjack is still in the lead. All right. Everybody got it. Good. Only one reasonable answer, huh? Only one reasonable answer. Well, that makes it easy. Good job. Okay. Ooh. Oh, interesting. What's the horizontal asymptote of this function? If you're not sure how to find horizontal asymptotes, look at your rules we talked about yesterday. That's x to the power of 1. That's x to the power of 1. If these are the same, your horizontal asymptote will be f of x, also known as y equals a over b. That's your rule, if and only if this power is the same as this power. Good luck. I kind of gave it away, didn't I? What? Oh, no. You're going to suffer? Well, at least I didn't tell him what b was. All right? I'm about to end it. I'm about to end it, just so you guys know. All right, I'm about to end it. I'm just about to end it. Oh, just in time. Just in time. So, what was the a value, everybody? 4. What was the b value? 1. What is 4 divided by 1? That's why the answer is y equals 4. All right? So, whenever you guys get this, whenever you have the same power, okay, all you got to do is just do 4 over 1 and bam, that's your answer. That's how you find horizontal asymptotes. It's that easy. Well, by the way, if you get it wrong today, is that going to impact your grade? No, because you're here and you're playing. All right, next one. Uh-oh. Oh my gosh, I got a factor. Oh, dadgummit. Well, this is a difference of squares, which factors to x plus 2 and x minus 2. And this right here, see here, would be x minus 3 and x minus 2, because negative 3 plus negative 2 is negative 5, and negative 3 times negative 2 is positive 6. So there's your, this is this factored, and there's this factored. Good luck. So if you're wondering what I'm doing, I'm putting x plus 2 over x minus 2 over x minus 3 and x minus 2. But I am not going to tell you where the removable discontinuity is, because that would be wrong. So if these cancel out, we have what's called what? Removable discontinuity. But what number would I plug in there to make this equal to 0? That's the number you are searching for. I'm not going to tell you what number you'd have to plug in there to make it equal to 0, because that would just be wrong. I'm about to end the question, because I basically gave away the answer. All right. All right. So let me go back to it real quick. Could you guys right now, hold on. Could you guys please write this down, show the factors, okay? I'll give you a chance right now. I'm going to go ahead and pause the video, write this down, and show the factors above it and below it, please. Okay? I'm going to go and pause if I can. Here we go. So we are going to go over everything there is to know about this particular problem. I'm going to go right over here. I'm going to write it down. We have x squared minus 4 over x squared minus 5x, and I believe it was plus 6, correct? All right. Now, we said we need to factor it, so this is a difference of squares, so that becomes x minus 2 and x plus 2. This factors to x minus 2 and x minus 3. And so if you have a function, there are different things you need to know how to do. One of them is dealing with what? Removable discontinuity. So we have removable discontinuity at x equals 2. All right? We have a 0. A 0 is located. What number would I plug in there to make it equal to 0? I'd have to plug in a negative 2. So we have a 0 at x equals negative 2. We also have a vertical asymptote. And the vertical asymptote is right down here. That's at x equals a 3. So that's at x equals 3. Lastly, but not least, we have what's called a horizontal asymptote. See how these powers are the same? If these powers right here, these powers are the same, we just do a over b. In this particular case, it's just 1 over a 1. That's what a over b is. So our horizontal asymptote is at y equals 1, also known as f of x equals 1. This is everything you need to know about that function. Okay? That's everything that you need to know about what I'm going to be asking you when you guys are taking a test. All right? You're going to be asked to find removable discontinuity, zeros, vertical asymptotes, and horizontal asymptotes. Okay? The only thing that I haven't added in today's quiz is the slant asymptote, but we showed you guys how to use it, so we'll go over how to find a slant asymptote just one more time. Not today, but we'll go over that. All right. Moving on to the next question. Let's see what you guys got. I don't know how people could get this question so fast. I'm not going to tell you guys any answers to this question, though. That would be wrong. All right. Well, I wasn't recording, but that's okay, because you know what? Those are still all the answers. There was the... Uh-oh. Oh, no. What's the horizontal asymptote? Quick, we only have 40 seconds. No. By the way, just relax. That's a 1, right? That's a 1. This is a 2. Look at your rule. This is less. All right? 1 is less than 2. All right? Don't worry, there's less than 37 seconds. Uh-oh. All right. Uh-oh. Oh, you chose none? Now, let me tell you, hey, can I show you what none would be? Check it out. If this right here was like to the power of 3 and that was to the power of 2, that would be no horizontal asymptote. However, there would be what's called a slant asymptote. Okay? So if this power up here, if this power is like a 5 and that's a 2, see how that's greater? That would be none. But anytime it's less, like this is to the power of 1, the answer is going to be y equals 0, unless I have like out here just for random, like I put like a plus 1, then it would be y equals 1. Or if I take, so understand, if it's just under a fraction, it will be y equals 0. But if there's a plus or minus, you got to pay attention to that as well. All right. David, you should be happy. Well, on this question, nowhere. All right. Hopefully everybody sees that this power is greater than this power. We just went over that. And I told them there was no happiness to be found. That was the hint. All right, guys, what's the horizontal asymptote? None. There is no horizontal asymptote. Now, would there be a slant asymptote? Could we find, if we wanted to, find the slant asymptote on this? Yes, because this is what, 1 degree higher. So if it's 1 degree higher, we could find the slant asymptote. And this is what I would like you guys to do. Right now, I need you guys to get your journal out. I need you to write this equation down. We are actually going to find the slant asymptote for this problem. Okay? This will be probably one of the last 2 things that we're going to do. All right? Now that you guys kind of have the hang of it, here's what I need you guys to do. Write this equation down. And then we need to practice what's called the little bit of long division. Okay? So we're going to do 2x cubed minus 4x squared minus 3x. And we're going to divide this pesky negative x squared plus 3 into it. And we're going to find the stinking slanted asymptote. All right? Write it down. Okay, now that you have it written down, you're like, Mr. DeMood, you're going too fast. We got to figure out what number would go right there to make this a 2x cubed. Somebody says negative 2x. I agree. Because a negative times a negative is a positive, and x times x squared is x cubed. Very good. Put a parentheses around this, and we're going to take it away. But wait a second. I got to distribute this to this guy. So negative 2x times 3 is what? Negative what? 6x. You see how I kind of try to put it? I probably need to do a better job. Ready? Hold on. I got to put minus 6x over here. Draw a line. So see how this will be brought down? So this zeroes out. What are we going to do with that negative 4x squared? We're just going to bring it down. A negative times a negative is a positive. So basically this becomes plus 6x. So we have what? Plus, no, 3x. A negative times a negative is a, so that literally becomes a what? A positive 6x, but I'm just going to leave it like that. Okay, so now, ready? Next one. Let's go orange. I bet orange looks really nice. Ooh, it does. Plus, we're getting close to Halloween. So, what number would I plug in right there to get to a what? Negative 4x squared. What? Yes. Very good. No, not 17, you knucklehead. All right. So, 4 times negative x squared is negative 4x squared. 4 times 3 is 12. What do we have to do with those? We have to take them away. These zero out. What am I left with? 3x. Then I have what? Nope. Minus 12. This is, what do we call this? We call this and we don't care about it. The only thing we care about for slant asymptotes is this right here. So our slanted asymptote would be, right now, y equals negative 2x plus 4. That would be the slant asymptote for this equation. So what we're going to do to prove this to you, I'm going to give you a chance. I'm going to pause the video. I want you to open up Desmos So open up a tab in your screen for Desmos, please. Open up Desmos. We're gonna type this function into Desmos, okay? So here we go. Gonna open up right here. Gonna go to Desmos, the beautiful free math graphing calculator. All right, and it was f of x equals, and we have a little fraction bar right there. Okay, so what was in the numerator? 2x cubed minus 4x squared. So 2x cubed minus 4x squared minus 3x. Okay, minus 3x. All right, and then what else? Negative, it was negative x squared plus what? Plus 3? Okay, so check this out. This is a funky looking graph. Can you guys see how the slant asymptote would come down right here? You guys see that? Now we said our slant asymptote was y equals, what did we come up with? Negative 2x plus, look at that. See how that fits? Right along that graph. Everybody see that? There's the slant asymptote right there. Nice. Okay. So once again, how do you find it? Yeah. How do you find your slant asymptote? You take this and divide it by this, and why did we have to use long division and we didn't use synthetic division? Because of that pesky x squared. Okay. All right. Moving on to a next problem, everybody. Next problem. Here we go. Get ready to go. Go back to your Quizziz screen. Go back to your Quizziz screen. Hurry, hurry. Go back to your Quizziz screen. What is the horizontal asymptote? What is the horizontal asymptote of this? Ooh, interesting. That is to the power of 1. That is to the power of 1. That number is 1. I wonder. Remember, how'd we do? How'd we do? Let's see what we did. What'd you guys get as the horizontal asymptote? 1 over 2. That's right. 1 over 2. Woohoo! All right. So why is it 1 over 2? Because these powers are the same, and this is the a value over the b value. So it's 1 over 2. All right. Ooh. What is the vertical asymptote? What is the vertical asymptote? What number makes the denominator equal to 0? You're 1 off, huh? That stinks. All right. So, by the way, quick question. What was negative 5? What does that do? That's called the 0 of the function. But what number would you plug in there to make it equal to 0? A positive 6. So that's why the answer is the vertical asymptote would be x equals 6. All right. Last question, everybody. Last question for today. what does the question ask us? What's the vertical asymptote? Okay, so we got to factor this. That's x minus 5 and x plus 4. So we're looking for what's called the vertical asymptote. That's what they're asking? All right, that's the vertical asymptote. Now, we have some removable discontinuity happening here and here. So basically, what you're looking for is what number would you plug in there to make it equal to 0? Oh, no. All right, what was the number we have to plug in there to make it equal to 0? All right. So you know what? We're going to hit exit. I know, but you just don't know what it's going to be. So congratulations to Clove Caulfield, cousin of Holden Caulfield. All right, good job, y'all. And that's it for today.